So in our last session, we did a few things. We discussed how to solve polynomial equations. That was by factorizing those polynomials. So if you have a higher power like this, you have to figure out a way to factorize the polynomial, right? So one way was using long division, the quotient that you get. So if you have one factor given, you can find the other factor by long division. Your quotient will be the other factor. Okay, so once you're done with that, you break that polynomial down into factors, and then you put them individually equal to 0 and find the values of x from that. That's one thing that we did. Then we said sometimes they don't tell us any factors at all, and we have to guess one factor, one solution ourselves. How do we do that? If we've got an equation like this, and we're not given any factor, we have to guess one solution ourselves first. And how do we do that? We just look at this constant term that we've got at the end, and we look at the factors of this term. So look at the factors of 2, both positive and negative. So it could be 1 and 2, plus minus 1 and plus minus 2. You check each of these factors, each of these numbers, and see if they satisfy this equation or not. You check 1, minus 1, 2, and minus 2. We did that, and we found out that x equals 2 is a solution. If x equals 2 is a solution, that means that x minus 2 is a factor. Okay, x minus 2 is a factor, so we know one factor. Once we know one factor, we can do division and find the other factor. Once we have the other factor, we can write down the factorized form and put that equal to 0, and then solve that after that. Okay, so this is what we did yesterday. And towards the end, we did this method of division called synthetic division that you can use when the divisor is linear. So this only works when the divisor is linear. That's a condition that we've got for this. So this was the process that we had for this division. We discussed this yesterday in detail. If the coefficient of x is 1, then you just do this process and you get the quotient directly. If the coefficient of x is not 1 already, like it was in another example that we did in this one, if the coefficient of x is not 1, like it's 3 in this case, then after you're done with this whole process, you do one additional step at the end, and that is that you divide by whatever number you've got here. So in this case, you've got 3. If this is the quotient that you're getting from the synthetic division, you have to do one additional step after that, and that is that you divide by this number 3 yourselves manually at the end, and that is what is going to give you the actual quotient from that, which is 4x squared minus 8x plus 3. And then after that, you just, do factorization like you've been doing before. That is what we did in our last session. Okay. Now, today we are going to do the last couple of concepts that we've got in this topic, and then we'll wrap this up. We'll see if we need to do any more practice after this, but probably not. Tomorrow, I would actually like to start with our next topic, that is binomial expansion. In fact, that's just a one-day topic. We should be able to do that tomorrow, inshallah. But we'll see. Okay, let's do this. If you have any questions on this, we can probably discuss them tomorrow. If not, we would want to move on to polynomials, inshallah. But let's discuss the last two concepts. First, let me do that using an example. This is not that worksheet. Let me open that worksheet first. Where is that? P3 polynomials worksheet. Okay, now let me start with a problem from here. Yeah, let's try this. This is question number 21 from this worksheet. Question number 21. Let's try this. Okay, the second part of this, we want to focus on this basically. When a has this value, so we'll find that value from the first part. We need to show that f of x, this function, is never negative. So we'll see how to think about problems like these. Okay, let's do the first part first because we don't have the value of a. Let's start from the first part for that reason. We've got a polynomial that's f of x. F of x equals x raised to power 4 minus 2x cube minus 2x square plus a. That is a polynomial that we've got. And we're given that this function is divisible by, what does that mean? Divisible by, that means this thing is a factor. It's divisible by x squared minus x minus 4x plus 4. This is a factor. X squared minus 4x plus 4. Okay. Given this, we need to find the value of a first. That's the first thing we've got to do. Now, what can we do? Can we use the remainder theorem here? Remember, what was the condition for remainder theorem? Remainder theorem only works when the divisor is linear. In this case, the divisor is not linear. Okay, so the first thing that should come to your mind would be that you can't use the remainder theorem here, at least directly. You'll have to use long division. Okay, even synthetic division doesn't work here because the divisor is not linear. So you'll have to do long division in this case. Okay, so you can do long division, and after you're done with that long division, you get a remainder at the end. You'll put that remainder equal to 0, and that's going to give you the value for a. That's one possibility. But if you think about it, there's actually a quicker way of doing this, and we can actually change the divisor in a way in this particular question that it becomes linear, or we can actually find the linear factors for these divisors. We can't make this linear, but we can actually split it further into its linear factors, because if you think, this is something that we can actually break the middle term for. We can do middle term breaking here. This can become x squared minus 2x plus 4, and that gives us x into x minus 2 minus 2 into x minus 2. So we get two factors from that, which are x minus 2 and x minus 2. X minus 2 and x minus 2. So we've got a linear factor now that x minus 2 is also a factor of this. So we write it as x minus 2 whole square as well. Some of you might be able to recognize that this is actually the form a square minus 2ab plus b square as well. So if you wanted, if you were able to figure that out, you could write this directly like this as well, x minus 2 whole square. But if not, you can just do middle term breaking like we did here and split it into two linear factors. Okay. Now, if this was a factor, x minus 2, which is something linear, this should also be a factor. This should also be a factor. Does that make sense? Just like if you had 24 and you knew that 8 is a factor of 24, right? 8 is a factor of 24. Now, any factor of 8 you can find further, for example, 2 and 4, These are also factors of 24, right? So factors of 8 are also factors of 24. That's the same thing that we're doing here. We are factorizing this further, and that's giving us x minus 2. Since x squared minus 4x plus 4 is a factor of this polynomial, these linear factors, they should also be factors of this polynomial. So in this particular question, we could actually find linear factor x minus 2. Now, once we know that, we know that we can use the remainder theorem here as well. Okay, so x minus 2 is a factor. We know that. So what value of x do we input here? We put this equal to 0, x minus 2 equals 0. We get value of x equals 2. We put this value of x in that function, and that gives us f of 2 equal to 2 raised to the power 4 minus 2 into 2 raised to the power 3 minus 2 into 2 squared plus a. Now, since x minus 2 is a factor, this remainder should be equal to 0. So we put this equal to 0. We get 16 minus 8 plus a, and the value of a turns out to be 8. So you were saved from that long division process. You could just do this directly like this. Suleiman, yes, that's correct. You can still use long division as well, and that will work. That's going to be slightly longer, but that will also work. So you just have to divide this polynomial by x squared minus 4x plus 4. Find the remainder. That will be in terms of a. You put that remainder equal to 0, and that should give you the same result as well. So that should also work. All right, let's look at the second part now. Now it says when a has this value, show that f of x is never negative. Now, what is the polynomial? The polynomial is f of x equal to x raised to power 4 minus 2x cubed minus 2x squared plus a, which is 8 in this case. This is what the polynomial is. You need to show that this function is never negative. Now, what does that mean? That means its graph, whatever that is always above the x-axis. So if this is the x-axis, the graph always have to remain above the x-axis. It can't come down, right? That's what we need to show, that this function never has a negative value. It could touch the x-axis. Yes, that is possible. That it just touches the x-axis like this. But it can't go below the x-axis. It cannot be negative. All right, that's what you're being asked to show. Now, the problem is we don't really know anything about quartic functions. We don't know much about power 4 functions. We don't know how their graphs look like. We don't know what their turning points look like. We don't know much about this function. So as we do for solving equations, we break such polynomials down to smaller factors. We'll do something similar here, so it's easier for us to understand. We would want to convert it to quadratic or linear factors, okay? Because then we would be able to understand what's happening to this function better. Right now, we can't because we don't know anything about power 4 functions, all right? So we know one factor already. We know that x squared minus 4x plus 4 is a factor. How do you find the other factor? You do division for that. And as it turns out, actually, it would have been better in this case that you had done long division in the first part, because you need to do that in the second part anyway. All right, but we did not know that before. If you had read the second part already, you would have figured out that you need to do long division for the second part. So it would have saved you time if you did it for the first part as well, because then you could just use that result from there. But anyway, we have to do this now. Let's do this. We need to divide x raised to power 4 minus 2x cubed minus 2x squared. Remember, the x term is missing. So that's 0x plus 8. We need to divide this thing by this factor. and find the other factor that's going to come in the quotient. X squared minus 4x plus 4, let's divide it by that. X squared minus 4x plus 4. Okay, let's do this division. What do we multiply x squared by to get x raised to power 4? We multiply by x squared, x squared into this whole thing. That gives us x raised to power 4 minus 4x cubed plus 4x squared. Now change the signs. This becomes minus, plus, minus. This gets cancelled, and we have 2x cubed minus 2x cubed plus 4x cubed. That's 2x cubed. Minus 2x squared minus 4x squared. That's minus 6x squared. Then you have 0x plus 8. What do you multiply x squared by to get 2x cubed? You multiply it by 2x. 2x into this whole thing now. That's 2x cubed minus 8x squared plus 8x. Again, change the signs. This becomes minus, plus, minus. This gets cancelled. And we have 2x squared minus 8x plus 8. What do we multiply x squared by to get 2x squared? Multiplied by 2. 2 into that whole thing, that's 2x squared minus 8x plus 8. Everything is cancelled, and you get a remainder of 0. That confirms that your working is correct because you're getting 0 remainder. This was a factor. You should have got 0 remainder. But what's the other factor now? The other factor is this. X squared plus 2x plus 2. So that function that you had in the beginning, f of x, that can actually be written in factorized form like this. X squared minus 4x plus 4 multiplied by x squared plus 2x plus 2. These are the factors that we've got for that polynomial, for that function. Okay. Now, these are functions that you know about. You know about these two functions. You know how they look like. These are quadratic functions, right? This and this. This was something that you did not know anything about. So we have simplified it a bit in that sense. Now, what we have to do is we have to show that this f of x is never negative. We have to show that this is never negative. How do we do this? We look at each of these functions separately, and we think about what they look like. Never negative could be that we have one of these, we have both of these positive. So this is also positive and this is also positive. That could be one way of getting a positive result. Another way could be that both are always negative, because that would then give us minus into minus. The result is going to be positive, right? So it could be one of these two things, most likely. Let's try to think about both of these functions. These are both quadratic functions. Let's see how they look like, how their graph looks like. Okay, so all of you, I'm assuming, know quadratics. What is the graph of this function? How does this look like? It's a U-shaped graph. It's a U-shaped graph and it looks like this. What about the second graph? This is also a U-shaped graph. This also looks like this. Now, how do we know whether these functions are positive or negative or both? We don't know where the x-axis is. It could be here. In this case, the upper part is positive, the lower part is negative. It could be here. In this case, it's just touching 0. So it could be 0 or positive. Or the x-axis could be below here. In that case, this whole curve is always positive. It could be any of these cases, right? How do you figure out which one of these cases it's going to be? You look at the turning point. Remember, how did we used to find the range of quadratic functions? We used to think about the turning point of the graph. That's what we do here. We find the turning point of both graphs. Find the turning point of this graph and also of this graph. Now, there are a number of different ways of doing that. You could complete the square for both of them. You could use minus b over 2a. whatever you prefer. I'm going to use minus b over 2a for both of them one by one. Let me do that for the first function. X equals minus b over 2a, right? That's what I'm doing to find the x coordinate of the turning point. Now, for the first thing here, I'm going to get minus b, that's minus into minus 4 divided by 2 times 1. And this turns out to be 4 over 2, that's 2. What about the corresponding y coordinate? Put this back in this function, x squared minus 4x plus 4. That's 2 squared minus 4 into 2 plus 4. What do we get from this? This gives us 0. So that means the turning point of this function is 2 and 0. All right. So where's the x-axis going to be? It's going to be like this. This graph is just touching the x-axis. It's never negative. It can either be 0 when it touches the x-axis. It's equal to 0 at this point, or it's something positive. That's what we have found from this reasoning. Okay. Let's look at the other factor now and think about what's happening to that factor. So this, we have figured out this is 0 or positive. Okay, this could be either 0 because it's just touching the x-axis, or it could be 0, that means it's positive. It could be positive. Let's look at the other factor, x squared plus 2x plus 2. Let's do the same thing on that as well. X equals minus b over 2, so that's minus 2 over 2 times 1. That gives us x equals minus 1. Put this back in this expression. That's y equals x squared, that's minus 1 squared, plus 2 into minus 1, plus 2, and that gives us y equal to 1 minus 2 plus 2, that is 1. So this turning point is minus 1 and 1. Where's the x-axis going to be for this? You see the y coordinate is 1. That means it's something positive, right? We look at the y value to figure out the value of the function. In this case, since the y value is positive, that means x-axis is going to be below this. Okay, so this whole function is going to be above the x-axis like this. It's always positive. Okay, so what we have figured out is this is what the function was. F of x equals x squared minus 4x plus 4 into x squared plus 2x plus 2. This is what it was, right? What we have done is we have found the minimum point of both functions. Minimum value of this function, what's this? It's 0 for this function. Remember, when we talk about minimum or maximum value, we're talking about the y value. Minimum value for this function is 0. Minimum value for the second function is 1. For the second function, the minimum value is 1. Now, if you multiply a number that's greater than 0, greater than or equal to 0, by a number that is greater than or equal to 1, what is the result going to be? The result is also going to be greater than or equal to 0. You cannot have a negative result. That means it's never negative. What's the working that you'll have to show for this? You'll have to first factorize. This is the important thing. You show the two factors, and then you say, then you just find the turning point somehow. You find that the minimum point for the first factor is 0, and the minimum point for the minimum value for the second factor is 1. So the product can also not be negative. It also has to be greater than or equal to 0. And that proves that f of x is never negative. Does that make sense? This is slightly tricky. The slightly trickier part of this topic as compared to the other concepts that we've done. all you have to do is whatever polynomial you have, you're going to break it down into factors first. Okay, so mostly it's going to be quadratic and linear factors. Then you think about that quadratic factor, what its graph look like, you look at the turning point, and then give your reasoning based on that turning point. You could have, so in this case, it says prove that it's never negative. You could have other similar problems like this. They could ask you to prove that something is never positive, or something is always positive or always negative, things like that. You use exactly the same method for all of them. You factorize first, and once you've factorized, you look at the turning points of the quadratic function and then reason based on that. Is this clear to everyone? Any questions? Make sense? Uh, Zoya, you're right about the first one. You're right about the first one. You could write this as x minus 2 whole squared. So this is a square. We know it cannot be negative. Yes, it works for the first one, but this is not x plus 1 whole square. This is x plus 1 whole square plus 1. Okay. And that is something that we have to do completing square for. So if you can figure that out, or if you can do this mentally, some people are able to do that they are able to write this thing directly like this. So if you are one of them, then you could do it. You could say you've got a square plus 1, so that's why this is also positive. So the product is also going to be positive. Okay. But that's only in this particular question, right? So this is the general method that we've done that will work in every such question. Okay. So this being a perfect square is just specific to this problem, right? You might not have a perfect square in another problem. So for that, you'll have to do this. You'll have to use the turning point thing. And similarly for this, in this case, it's quite easy to figure out that this is x plus 1 whole square plus 1. But in another function, you might have to do the whole completing square process to convert it to a form like this, and that would be more complicated. So this is a standard thing that you can use. Just find the turning point, and then based on that turning point, argue that the whole thing is going to be either positive or negative, whatever the question is asking for. Make sense? Okay, now let's look at the last concept that we need to do. And that is, we would sometimes need to solve cubic inequalities. It could be cubic inequalities. It could be quartic as well. Mostly they ask for cubic. Let's think about this now. All right, solving cubic inequalities. Okay, so this is another tricky part of this topic. There are actually multiple ways of thinking about this. Let me actually write down an example first, and then we'll think about that. Let's say we have to solve this inequality. Solve x minus 2 into minus x squared plus 4x minus 10 greater than 0. We want to solve this inequality. All right. Now, how do we think about it? First of all, there's a wrong way to do it. So I'll just write that down so that you know what not to do. It's a product, and that's greater than 0. you will be tempted to just do this x minus 2 greater than 0 or minus x squared plus 4x minus 10 greater than 0. But that's wrong. You can't do that. That doesn't work for inequalities like this. It works for equations that if a product is equal to 0, then either the first factor is equal to 0 or the second factor is equal to 0. But that does not work for inequalities, right? Because so what you're doing here is it's basically saying that both of them have to be greater than 0 for the product to be greater than 0. But you could also have two negative numbers for which the product is greater than 0. For example, if I have two numbers here, one possibility for making the product 0, product positive is that we have both positive numbers, but we also have two negative numbers that give us a product of greater than 0. So that's why we can't say that both are greater than 0. Okay, this is not correct. You can't do this. All right, now what do we do then? If we can't split it like that, how do we go about solving this? First of all, there's one method that uses arguments similar to what we have done here. Okay, what we've done here that we look at the factors, look at the turning points, and then based on that, we try to solve that somehow. Okay, I'm not going to do that. There is a way of doing it this way, but I've experienced that a lot of students do not give complete working for that method in the exam. They miss some parts of it and then they end up losing marks for that. And that's a bit more confusing as well. So I'm going to skip that method altogether. Let's discuss one method that is very similar to what we used to do in modulus inequalities, because that was a general method that works for every kind of inequality. That is what we're going to use here, and that can solve any kind of cubic inequality as well. Let's see how that works like. So remember how we used to solve modulus inequalities? If we had an equation, the first thing we used to do, if we had an inequality, the first thing we used to do was, we used to say, let's treat it as an equation. That's how we start. Treat this as an equation. So this is how we're going to solve cubic inequalities. Treat the inequality as an equation first. Okay? Treat it as an equation. Now, can we solve this equation? We already have factors. We can say either x minus 2 equals 0 or minus x squared plus 4x minus 10 equals 0. The first one gives us x equals 2. Let's solve the second one. This is x squared minus 4x plus 10 equals 0. If we were to solve this equation, can we factorize? We can't. Let's use the quadratic formula. Minus b minus into minus 4 plus minus square root of minus 4 whole squared minus 4 into 1 into 10 divided by 2 into 1. And you figure out you have no solutions for this. You have no real solutions for this. So you're not getting anything from here. You've got only one answer, which is x equals 2. So if this was an equation, x equals 2 would be a solution for that. All right. Now, what you do after this is you draw a number line. This is your critical point. And that critical point is 2 here. It divides your number line into two regions, one to the right of 2 and one to the left of 2. And now you need to see which side of this number satisfies this inequality. Okay. Now, what is this inequality? Greater than 0. Just input, take one value to the left of 2, one value to the right of 2. One easy value to work with on the left side would be 0. And we could take a value on the right as well. Let's take 3, for instance. And let's input these numbers in that inequality got written on top. X minus 2, so that's 0 minus 2, into minus x squared, that's just minus 0 squared, plus 4 into 0, that also becomes 0, minus 10 greater than 0. What do we get from this? Minus 2 into minus 10, that's greater than 0. And from this, we're getting 20 greater than 0. Is that correct? That is correct. That means this region is going to be correct. Okay. Now, it's going to be pretty obvious that the second region is not going to be correct here, but you're still going to do the working because because you need to be sure that you haven't done any mistake here. So you need to make sure that the second number is giving you an incorrect answer. Let's try that. Let's input 3 there. Put 3 in place of x. That gives you 3 minus 2 into minus 3 squared. Remember, minus is outside the square. This is going to be minus 9. Plus 4 into 3 minus 10. That's greater than 0. That was the inequality. Let's simplify this. We have 1 outside. Inside, we got minus 9 plus 12 minus 10 greater than 0. And this is giving us minus 19 plus 12, which is minus 7 greater than 0. And we know that is incorrect. Is the working fine here? Minus 9 plus 12 minus 10. Okay, all right. So you're getting minus 7, that's greater than 0. This is turning out to be incorrect. So on the number line, this is correct, and this region is incorrect. Incorrect. So what is going to be your final answer then? It's everything towards the left of 2. So you say the answer is x less than 2. This is the solution to this inequality. Make sense? If you were to do x minus 2 greater than 0 here, using that incorrect method that we discussed in the beginning, it would have given you x greater than 2, and that would have been wrong anywhere. If by chance you got the correct answer using this incorrect method, you will still not get marks for that because that would be incorrect. Okay, maybe 1 out of 3. So you can't do that. You have to follow this whole process. Acha, by the way, in modulus inequalities, it was not necessary to show this working, the number line working. If you could do it mentally, that was acceptable. You could just write down the final answer with using mental calculation as well. But you'll find out when you have cubic inequalities, they will always ask you to justify your answer, just to make sure you're not getting the correct answer just by guessing. Okay? Or tukka nahi lag raha. So they will require you to do that working. Let me show that to you. Inequality. Can you find an inequality? Yeah. The very first question, you see, it says solve the inequality p of x greater than 0, justifying your answer. It's going to be important to justify your answer. Okay, justify your answer. That means you've got to show complete working, complete reasoning. So you'll have to show this number line and then show this working, that this region is coming out correct and this region is coming out incorrect. That is going to be important for cubic inequalities like this. Okay. Now, let's do one example on this before we end. That then concludes our polynomials topic. For the most part, there is actually one question that I still want to do. Let me see if we should do that today or... okay, so let's be quick about it and do one question right now. In fact, 2 questions right now. Okay, so can we extend it by 5 minutes? Yeah, we'll try to do that. Let's extend it to 7:35 so that we can just wrap this topic up and we don't have to spend time on this tomorrow. Let's do this example first. This is question number 5 from the worksheet. Question number 5 from the worksheet. Let's have a look at this. Actually, I talked to you about this already, that we could extend the P3 class timings by a little. So yeah, we will do that today. We'll do that for 5 to 10 minutes to complete this topic today, okay? Because we missed a number of classes already. We need to make up for them. So we are going to extend this class a little. We'll do 2 more questions, one this and another more after that. Okay. And these are very important questions. This one is on inequality and the other one is from a recent paper. And that's really, really important. So you need to make sure that you are here for that. The polynomial, this is denoted by p of x. It's given that p of x is divisible by 2x squared minus 3x plus 3. Divisible by this, what does that mean? It's a factor. 2x squared minus 3x plus 3 is a factor. Okay. We need to find the value of a given this information. Now, it's a quadratic factor. We can't use remainder theorem unless we could somehow factorize this. You can think about it. Can we factorize this? Is it possible to break the middle term? It's not. So you'll have to use long division. Okay. Let's use long division and see what that gives us. 4x cubed minus 4x squared plus 3x plus a. This is what the polynomial is. We want to divide it by 2x squared minus 3x plus 3. Now let's follow through the long division process. 2x squared multiplied by 2x is going to give us 4x cubed. 2x into that whole thing, that's 4x cubed minus 6x squared plus 6x. Let's change the signs. Minus plus minus, this gets cancelled. And this gives us 2x squared minus 3x plus a. What do you have to multiply 2x squared by to get 2x squared? By plus 1. So you've got plus 1 here. 1 into that whole thing, that gives us 2x squared minus 3x plus 3. Change the signs. Minus plus minus, this gets cancelled. This also gets cancelled. And we're left with a minus 3. Now this is the remainder. Now, since it was a factor, the remainder has to be equal to 0. So we put this equal to 0. A minus 3 equals 0, and that gives us a equal to 3. So the value of a that we've got is equal to 3. All right, now it's good that we've done long division because now we've found the other factor of that polynomial as well, which is 2x plus 1. It says when a has this value, solve this inequality p of x less than 0, justifying your answer. Okay, you have to solve this inequality p of x less than 0. Now, what is that polynomial? Let me write that here first. 4x cubed minus 4x squared plus 3x plus a, that is less than 0. We have the value of a now, that's 3. Let's put that here. This is the polynomial that we've got. Now, how do we solve this inequality? We can factorize this. We already have one factor. The other factor is 2x plus 1. Now, let's write that down here. 2x squared minus 3x plus 3 whole multiplied by 2x plus 1 is less than 0. So this is what the factorized form looks like. Okay. Now, what do we do after this? We treat this as an equation. We say 2x squared minus 3x plus 3 whole multiplied by 2x plus 1 equals 0. Solve this equation to find that critical point. This gives us 2x squared minus 3x plus 3 equals 0, or 2x plus 1 equals 0. Solve this, you'll find out it does not have any solutions. That is actually going to be the case in most of these cubic inequalities that you'll be solving. You won't be getting anything from the quadratic factors generally, but you can just try that. Minus b, that's minus into minus 3, plus minus square root of minus 3 whole squared minus 4 into 2 into 3 divided by 2 into 2, you figure out that the thing inside the square root is negative, so it has no solutions. So the only solution that you've got from this is x equals minus 1 over 2. This is that critical point now. You draw a number line. Now it's important to show this process. Draw a number line. This is minus 1 over 2. Take one number to the left of it, one number to the right of it. One number to the left of minus 1 over 2, we could take minus 1 here. One number to the right of minus 1 over 2, we could take 0 here. Let me write down the inequality. Let me use this one. It's easier to just input in the original inequality, 4x cubed minus 4x squared plus 3x plus 3, that's less than 0. Just input minus 1 once in that and then 0 and see which of them satisfies. 4 into minus 1 cube minus 4 into minus 1 squared plus 3 into minus 1 plus 3 is less than 0. What do we get from this? Minus 4 minus 3 plus 3, that is less than 0, and that's minus 8 less than 0. That's correct. Let's try the region on the right as well. If you input 0, you get 0 minus 0 plus 3 less than 0, and that gives you 3 less than 0. That's incorrect. So that means the region on the left side here is going to be your answer. This region is correct. This is incorrect. So the final answer, therefore, for this reason is x less than minus 1 over 2. That is your final answer here. Does this make sense to everyone? Any questions on this? Any problems? If you don't want to speak, there should be a button on your Zoom, like thumbs up or something. You can show some reaction that you understand. So I know we can move on. Okay, that's good. All right, let's do one last question and then we end. Then we wrap this topic up. This is not in the worksheet. It's from a recent paper, but it's an important one because it clears one concept that you need to be clear about. Let me see where I can find that question. Oh yeah, it's this. Copy. Okay, this is from a recent paper. I'm not sure which paper it exactly is. We'll just solve this. That's what is important. Okay, let's just do this last question and then we wrap this topic up. Tomorrow we'll start with binomial then, inshallah. All right, this is what the question is. The polynomial 4x raised to power 4 plus ax squared plus 11x plus b, this polynomial where a and b are constants is denoted by p of x. It's given that p of x is divisible by x squared minus x plus 2. That means this is a factor and the remainder is 0. Okay. Now, given this information, we need to find the values of a and b. Now, the first thing is, can we use the remainder theorem here? We can't because it's not a linear factor. That's not going to work. So the other option that we've got is that we use long division. Let's do that. 4 x raised to power 4. The x cubed term is missing. Be careful about that. So that's 0x cubed plus 11, no, so plus ax square plus 11x plus b. This is what the polynomial is. We want to divide it by x square minus x plus 2. You have to do this division and then find the remainder, put that equal to 0, and that should somehow give you the values for a and b. Let's try this. What do you multiply x squared by to get 4x raised to power 4? You multiply it by 4x squared. That's the first thing that you have. 4x squared into this whole thing. That is 4x raised to power 4 minus 4x cubed plus 8x squared. Change the signs. This is minus, plus, minus. This gets cancelled. And we get 4x cubed minus, no, now this is important. So you've got ax squared and minus 8x squared. What you're going to do is you're going to write it like this. What's the coefficient of x squared? The coefficient of x squared is a minus 8. So write it like this. A minus 8. This whole thing is the coefficient of x squared. All right. Now, what's the next thing here? 11x. And then we have plus b. What do you multiply x squared by to get 4x cubed? You multiply it by 4x. Now, 4x into this whole thing, that gives us 4x cubed minus 4x squared plus 8x. You have to be careful that you're writing like terms under like terms. So x squared below x squared, x below x. Otherwise, you'll get confused by that. So we're done with this. Now change the signs. This becomes minus. This becomes plus. This also becomes minus. This gets cancelled. What do we get now? A minus 8 plus 4. A minus 8 plus 4. That gives us a minus 4. So the coefficient of x squared that you're getting here is a minus 4 whole times x squared. 11x minus 8x. 11x minus 8x, that's going to be 3x. Then you've got plus b outside. What do you multiply x squared by to get a minus 4 times x squared? You multiply it by a minus 4. X squared multiplied by a minus 4 is going to give you a minus 4 whole x squared. Now, this is why it's really important that you write it like this, in this form, because if you had written it like this, ax squared minus 4x squared, it's very likely that you would have written just a here, because x squared times a gives you x squared, but you also need minus 4. So you would have missed out on that if you wrote it separately like this. So don't do that. Write it together like this, and that will make sure that you don't do this mistake. A minus 4 whole times x squared. This is the term that you're getting here. Okay. Now, we have to multiply a minus 4 with this whole thing. What does that give us? A minus 4 into x squared. And then a minus 4 into minus x. What's that? So you've got a minus sign here. Put that here. Minus into a minus 4 times x. Then 2 into a minus 4. That's 2a minus 8. This is your constant term. 2a minus 8. What do we do now? We change the signs again. This becomes minus. This whole thing gets cancelled. This becomes plus. So 3 plus a minus 4. 3 plus a minus 4. Right? This 3 and then a minus 4. What does that give us? That gives us a minus 1. So you have a minus 1 times x plus b plus 2a minus 8. b plus 2a minus 8. This is the constant term that you're getting. Okay. Now, what multiplied by x square is going to give you a minus 1 times x. Now you can see this degree is lower than this degree, so we can't go any further. This is our remainder. Now, since x square minus x plus 2 was a factor, the remainder has to be equal to 0. Now, here's the trick. This remainder has to be 0 for all values of x. No matter what value of x you input here, this remainder should be always equal to 0. Okay? What that means is this coefficient of x, this should also be 0. Because when this becomes 0, this multiplied by x is going to make it 0. And this constant term, this should also be equal to 0. So both of them individually have to be equal to 0. All right? And that gives you two equations. A minus 1 equals 0. That gives you a equals 1. That's the value of a that we've got. And then we have b plus 2a minus 8. You input that equals 0. You put the value of a here in this equation. That's b plus 2 into 1 minus 8 equals 0. And you get b equal to 6 from this. So a equals 1 and b equals 6. These are the two answers that we're getting from this. Does that make sense? So the key part here is writing these coefficients in proper form, because that's going to make your calculations easier, make your working easier. And then the remainder that you get at the end, you put every term individually equal to 0, as in x term, you put that equal to 0, and the constant term, you put that equal to 0. And from that, you get those unknowns that you have to find there. Okay, I'm sorry. I think there's something wrong that we've done here. We missed, so nobody pointed that out. I haven't changed the sign at the end. So when we did this last edition, maybe it got undone for some reason when I pressed some button. So there was a minus sign here, right? So it was not plus. We had to subtract it from that. So this becomes b minus 2a plus 8. Okay, so there's a sign error there. B minus 2a plus 8. And that gives us b minus 2a plus 8 here. And this is b minus 2 into a plus 8. Now b plus 6 goes to the other side and becomes minus 6. The value of b is not 6, it's actually minus 6. Sorry about that. This is what we get. Okay, so I missed that minus sign here. This is what it should be. Is this clear to everyone? Any problems with this? Or you're too tired for questions now? Okay, so let's do this last part and then we end. When a and b have these values, find the real roots of this equation. Now, this is pretty straightforward once you've done this. Real roots of the equation, p of x equal to 0. What's p of x? P of x is that polynomial, 4x raised to the power 4 plus ax square plus 11x plus b equals 0. This is the equation that we need to solve. We already have the values for a and b now. A is 1, so this is x squared. B is minus 6, so we can put minus 6 here. We need to solve this equation. Now, it's a quartic equation. We don't know how to solve this. So what we do is we factorize this. we've already done all the work, all the hard work above. We know the factors. One factor is x squared minus x plus 2. We put that here. What about the other factor? This is the other factor, 4x squared plus 4x. 4x squared plus 4x. And then you have plus a minus 4. The value of a is 1. Then minus 4. So that's plus 1 minus 4. That becomes minus 3 there. And this equals 0. So we have these two factors. We put them equal to 0 one by one. X squared minus x plus 2 equals 0. Or 4x squared plus 4x minus 3 equals 0. What does the first one give us? Can we factorize this? We can't. We put this in the quadratic formula, minus into minus 1 plus minus square root of. I think it's not going to be possible. Let's just write it down. Minus 1 whole squared minus 4 into 1 into 2 divided by 2 into 1. You have a negative number inside the square root, so there are no real solutions from here. Yeah, we're only looking for real roots. Let's solve the other one. Can we factorize this one? We probably can. 4 and 3, that's 12, 6 and 2. We could use 6 and 2, 4x squared plus 6x minus 2x minus 3 equals 0. This gives us 2x into 2x plus 3 minus 1 into 2x plus 3 equals 0. You have two factors, 2x minus 1 and 2x plus 3 equals 0. X equals 1 over 2 or x equals minus 3 over 2. These are the two solutions that you get from this equation. All right. And that's it. That's polynomials done. We are done with all the concepts that we needed to cover in this, and we've done enough practice as well. You can do more questions now from the worksheet. If you have any problems, as I said earlier, what you have to do is you have to take a picture of your working, post it in the WhatsApp group, and ask your question. Once you have once you have posted your working as well, I'll be able to tell you where you're going wrong and suggest you what you could do there. So that's something that you can use as well. You can post your questions on the WhatsApp group. Tomorrow we are starting binomial expansion, and your worksheets are also due this weekend. Please make sure that you're submitting the polynomials worksheet by this weekend. Okay. If you are not doing practice, it's going to be difficult to get your concepts clear. Please make sure that you're doing that. You're practicing along with the concepts that we're covering, because that is what is actually going to help you retain all of this that we're doing. Okay. So that's it. If you have any questions, you can let me know. Otherwise, that is it for today. Any problems, anyone?
No, sir.
No. Okay, good. So I'll see you again tomorrow, inshallah. Allah Hafiz.